On October 19, 2017, a telescope on a volcano in Hawaii photographed something that had never been seen in all of recorded history. An object inside our solar system that did not belong to it. It came from another star. And within weeks, it did something no comet and no asteroid has ever done. It accelerated, with no engine, no fuel, and no explanation. Since that night, it has happened twice more. 3 visitors from interstellar space in 8 years. One broke the rules of physics as we knew them. One seemed normal until it cracked apart. And the third, the biggest and oldest of them all, possibly older than our sun itself, swept through the solar system just months ago. It is leaving right now as you watch this. This is case file number 3, and it's a triple file. Tonight, the visitor that tumbled end over end and sped up like something was pushing it. The Harvard professor who stood up and said the word everyone else was afraid to say. The amateur stargazer who beat every billion-dollar observatory on Earth to visitor number 2. And the ancient object that just flew past us, trailing metal vapor that had chemists scratching their heads. By the end of this file, you'll know why some scientists believe we've already been visited, why most believe something even stranger, and why the next 10 years will settle the question forever. Open the file. Act 1. The Scout. To understand why October 2017 changed astronomy forever, you first need to understand a simple, beautiful rule that had never once been broken. Everything in our solar system is trapped. Every planet, every asteroid, every comet, every grain of dust is a prisoner of the sun's gravity, looping around it in closed orbits forever. Which means every object we had ever tracked across 400 years of telescopes eventually comes back. Halley's Comet returns every 76 years. Even comets from the deep freezer of the Oort cloud, on orbits lasting millions of years, are still on a leash. The leash can be long, but it is always there, until the night it wasn't. That night, on the summit of Haleakala volcano in Hawaii, a telescope called Pan-STARRS was doing its boring nightly job, photographing the sky, hunting for asteroids that might threaten Earth. An astronomer named Robert Warwick was reviewing the images when he noticed a faint but moving fast. Unusually fast. He flagged it. Routine, so far. But when the orbit calculations came back, they made no sense. The computer kept spitting out a curve that wasn't a loop. It was a slingshot, an open curve, a hyperbola. This object was not bound to the sun. It hadn't come from the Oort cloud or the asteroid belt or anywhere on our map. It had fallen in from the space between the stars, and it was already on its way back out. Forever. Astronomers gave it a designation that had never been used before, 1I, the very first interstellar object, and a Hawaiian name, Oumuamua, a scout, a messenger from afar, arriving first. Which raises the obvious question the whole world started asking. Arriving first, ahead of what? Now, here's where the story stops being a nice discovery and becomes a genuine mystery. Because the more astronomers measured Oumuamua, the weirder it got. Every large telescope on Earth dropped what it was doing and swung toward this thing, because they had days, maybe weeks, before it was gone forever. What they found still has no agreed explanation. Weirdness number 1, its shape. As Oumuamua tumbled, its brightness rose and fell by a factor of 10, far more than any asteroid we'd ever recorded. The math pointed to something absurdly stretched, maybe 10 times longer than it is wide. A cigar. Or, some argued, a flat pancake. 400 meters of something shaped like nothing else in the sky. Weirdness number 2. It was tumbling. Not spinning neatly like a planet or a healthy asteroid, but chaotically, end over end, like a bottle flipped across a room. That kind of tumble usually means violence. A collision, an ejection, something, at some point, hit this object hard enough to send it spinning through the galaxy, and in the vacuum of space, it may keep tumbling for billions of years. Because this is the one that started the fight. As Oumuamua rounded the sun and headed back out, It was moving faster than gravity alone could explain. Something was pushing it. The push was small, but it was real, confirmed independently by multiple teams. Rocks do not do this. Rocks fall exactly the way gravity says they should. And we know exactly how. Sunlight boils their ice, gas jets off the surface, and the comet gets a gentle rocket push. It's messy and it's visible, a glowing cloud, a tail millions of kilometers long. So when Oumuamua accelerated, everyone said fine, it's a comet. One problem, the telescopes saw no tail, no gas, no dust, nothing. The deepest images from the biggest telescopes, and even a search by an infrared space telescope, found no trace of the exhaust that was supposedly pushing this thing. An invisible engine, accelerating a 400-meter object shaped like nothing we've ever seen, tumbling out of the galaxy. You can see why things got heated. And before we even get to the explanations, here's the detail that makes Oumuamua feel less like an object and more like an encounter. When astronomers rewound its trajectory, they found it hadn't been shot at us from some nearby star. Its incoming motion was eerily close to what astronomers call the local standard of rest, the average drift of our whole galactic neighborhood. In other words, Oumuamua was almost standing still by the galaxy's standards. It wasn't racing toward the sun ran into it. Sitting still in the middle of the road is, depending on your mood, either exactly what ancient drifting debris would do after eons of being nudged by the galaxy, or exactly where you'd park a buoy if you wanted passing star systems to run into it. Same data, two very different feelings. Keep both in your pocket because they're about to collide. Because yes, somebody did check for a radio signal. The Breakthrough Listen project pointed the Green Bank telescope, one of the largest steerable dishes on Earth, directly at Oumuamua and listened across billions of channels. If it had been transmitting with even the power of a mobile phone, we would have heard it. The result, silence, which settles nothing, of course. Rocks are silent. But so is a probe with a dead battery, 100 million years past its warranty. Enter Avi Loeb, the chair of Harvard's astronomy department, a man with hundreds of mainstream papers to his name. In 2018, he and a colleague published a paper making an argument most scientists wouldn't even whisper, that the numbers fit a thin, flat object being pushed by sunlight itself. A light sail. And a light sail is not something nature builds. It's something a civilization builds. The backlash was enormous. Colleagues accused him of chasing headlines. But Loeb kept asking a question that's harder to dismiss. If it's natural, then show me the natural explanation that fits all the data. And here's the uncomfortable truth. Years later, there still isn't one that everyone accepts. There are candidates. Each one solves part of the puzzle, and each one has a problem. Candidate 1, the hydrogen iceberg. A chunk of frozen hydrogen would push itself with an exhaust our telescopes literally cannot see. Elegant. Except frozen hydrogen is so fragile that many researchers calculate it should have evaporated crossing interstellar space before ever reaching us. Candidate 2, the nitrogen shard. A piece of a shattered Pluto-like world, made of nitrogen ice, like the glaciers we photographed on Pluto itself. Also nearly invisible when it evaporates. But critics ran the numbers and argued the galaxy simply can't make enough of them. Candidate 3, the cosmic dust bunny. An ultra-fluffy aggregate, 100 times emptier than air, light enough for sunlight to shove around. Except nobody can quite explain how something that flimsy survives a billion-year journey and a slingshot around a star. Notice the pattern. Every natural explanation requires an object unlike anything we have ever observed. That's the trap of Oumuamua. Even the boring answers are extraordinary. We even know its color, and the color tells its own story. Oumuamua reflected light with a reddish tint, the same weathered blush we see on the oldest surfaces in our solar system. Ice and rock that's been sandblasted by cosmic radiation for eons until organic molecules char into a dark crust. Whatever it is, its skin is ancient. This was not something fresh. This was something that had been out there a very, very long time. There's one more suspect worth naming, because it's the most poetic. Maybe Oumuamua is a tombstone. Some models suggest elongated shards like this are carved when a planet or comet wanders too close to a dense dead star and gets stretched and shredded by tides, its fragments flung into the galaxy like shrapnel. If that's true, we watched a piece of a destroyed world sail past us, still tumbling from the moment of its death, millions or billions of years ago. A serious mission study called Project Lyra worked out that chasing Oumuamua isn't actually impossible. With a slingshot past Jupiter and a scorching dive near the Sun, a spacecraft launched in the coming years could catch it in the 2050s. Think about that pitch meeting. Give us billions of dollars in 30 years to chase a rock that's probably a rock, because if it isn't a rock, it's the most important object in human history. So far, no space agency has said yes. So far. And we will probably never know. Oumuamua is gone, racing toward the constellation Pegasus, already too faint for any telescope humanity owns. Some engineers seriously studied a chase mission and concluded that with a gravity slingshot around Jupiter, we could still catch it decades from now. The file sits open. The evidence flies away at 90,000 kilometers per hour. Whatever it was, we got one look. Act 2. The one that looked normal. After Oumuamua, astronomers around the world were desperate for a second visitor. Whole survey programs watched the sky. Algorithms hunted for hyperbolic orbits. Careers were staked on catching the next one early. So naturally, the next interstellar object was discovered by a guy in his backyard. Gennady Borisov is a Crimean engineer who builds his own telescopes by hand, in a workshop, as a hobby. On August 30th, 2019, scanning low on the dawn horizon where the big automated surveys struggled to look, he spotted a fuzzy blob that nobody had cataloged. He measured it, reported it, and went to bed. Within days, the orbit came back, hyperbolic, interstellar, visitor number 2. I love this part of the story because it's a reminder that the universe doesn't check your funding. One man, hand-built optics, and the right patch of sky at the right moment beat every professional observatory on Earth to one of the discoveries of the decade. It now carries his name forever, 2i/Borisov. And at first, Borisov was everything Oumuamua wasn't. It had a tail. It had a glowing coma of gas and dust. It looked, behaved, and photographed like a completely ordinary comet. Hubble tracked it for months. Astronomers exhaled. See, interstellar objects are just comets from other stars. Oumuamua must have been a fluke. The universe let us relax for about 6 months. Then the chemistry results came in. When astronomers measured what Borisov was made of, one number jumped off the page. Carbon monoxide. Borisov was gushing it, in some measurements around 10 times more relative to water than comets born around our sun. That's not a detail. That's a birth certificate. It means Borisov formed somewhere brutally cold, far colder than where our comets were born. The leading suspect, a planet-forming disk around a red dwarf, a small, cool star utterly unlike our sun. Think about what you're actually looking at in those Hubble images, then. A snowball assembled around an alien sun, in a system we will never visit, thrown across the galaxy, photographed by apes on a water planet as it passed through. Every pixel of that image is an artifact from another solar system. Visitors don't owe us anything. Borisov began to fall apart. In the spring of 2020, as it retreated from the sun, telescopes watched a piece of its nucleus break away and drift off. The heat of a foreign star, our star, had cracked it. It survived the crossing between suns, and our sunshine broke it. Beautiful. When astronomers studied how its dust scattered polarized light, Borisov turned out to be cleaner than any comet ever measured in our solar system. The comets we know have all been cooked, over and over, by close passes to the sun. Borisov had never been near a star's heat since the day it froze. We weren't just looking at a comet from another system. We were looking at the most pristine, untouched piece of creation ever to enter our sky. And the statisticians got to work on the bigger question. If 2 came through in 2 years, how many are out there? The estimates are staggering. At any given moment, calculations suggest there are likely thousands of interstellar objects inside the orbit of Neptune, right now, too small and dark for us to see. The solar system isn't a sealed room. It's a train station, and it has always been one. We just finally installed cameras. Borisov taught us 2 lessons that set up everything in Act 3. First, interstellar visitors are not rare freaks. 2 in 2 years means the galaxy is absolutely teeming with wandering debris, trillions upon trillions of objects, sailing between the stars right now. And second, each visitor carries the chemical fingerprint of its home star, which means these things aren't just rocks. They're messages. We just needed a big one, close enough, slow enough, to really read one properly. As for Borisov itself, it's still out there, cracked but intact, coasting back into the dark with a piece of our sunlight's damage carried on it forever. Somewhere in a few 100,000 years it may drift through another system, and if anyone is watching there, they'll catalog a strange, broken comet with chemistry that doesn't match their star. They will be right. It will be a message from a red dwarf they've never seen, postmarked once by our sun. In July of 2025, the galaxy delivered, and this time, it sent something enormous. Act 3. The Elder. On July 1st, 2025, an automated telescope in Chile, part of a survey built to spot asteroids before they hit Earth, flagged a new moving dot. Within 24 hours, orbit solutions from around the world agreed on 2 things. 1. Hyperbolic. Interstellar. Visitor number 3. And 2. This one was not like the others. First, the speed. 3I/Atlas came screaming in at roughly 60 kilometers every second, the fastest solar system object of its kind we had ever tracked, so fast that our sun's gravity could barely bend its path. Second, the size. While Oumuamua was a few hundred meters, early estimates for Atlas pointed to a nucleus that could be measured in kilometers. The visitors were getting bigger. But the number that made astronomers sit down was its age. By tracing its motion backward, Atlas appears to come from an ancient population of stars in our galaxy's thick disk. Multiple analyses concluded this comet is probably older than our entire solar system. Read that again. The Sun is 4.5 billion years old. This object may have been drifting between the stars for 7 billion years or more. It was ancient before Earth existed. And unlike Oumuamua, which gave us weeks, Atlas gave us a proper visit. Every major instrument humanity owns got a turn. Hubble photographed it. The James Webb Space Telescope tore its light apart into chemical signatures. Even spacecraft at Mars joined in, because in early October 2025, Atlas passed closer to Mars than to Earth, and the orbiters there turned their cameras outward to catch it. Here's a detail from the Discovery Week that I love. Once astronomers knew where to look, they dug through archived sky images and found Atlas sitting in photographs taken weeks before anyone noticed it. It had been photographed repeatedly by multiple surveys and flagged by no one. A kilometer-scale interstellar visitor hiding in plain sight in our own data. Remember that, at the end of this file, when I tell you how many we think we've missed. The Mars flyby deserves its own moment. On October 3rd, 2025, Atlas passed within about 30 million kilometers of Mars, and the sharpest camera ever sent to another planet. The high-rise imager on NASA's Mars Reconnaissance Orbiter swung away from the ground it was built to study and photographed a visitor from another star. The image was a smudge of light, a few pixels of coma, and even those pixels started arguments online about what shape was hiding inside them. The results rolled in for months, and some of them were genuinely strange. Webb found the coma dominated by carbon dioxide, one of the most CO2-rich comets ever measured, another exotic birth certificate. It was already active far from the sun, earlier than expected. And then spectroscopy picked up something that made chemists blink. Nickel vapor glowing in the coma, without the iron that, in hot environments, usually comes with it. Nickel without iron sounds like a lab result, and headlines had fun with it, because one industrial process humans use, involving a compound called nickel carbonyl, produces exactly that kind of signature. Was it alien industry? Almost certainly not. Astronomers soon found similar nickel chemistry in some ordinary comets, driven by fragile nickel-bearing molecules that break apart in gentle sunlight. But for a few weeks, the universe let everyone enjoy the phrase industrial signature pointed at an interstellar object. And of course, Avi Loeb was watching. He and colleagues published a list of anomalies, arguing Atlas deserved scrutiny as a possible piece of technology, its unusually aligned path through the inner solar system, its timing, its arrival geometry. He even noted, half as a thought experiment, that its trajectory was oddly convenient for something wanting a good look at the inner planets. The mainstream pushed back hard. Every one of those oddities, they argued, has natural odds that aren't that extreme. Channels feasted on. As Atlas swung around the sun in late October 2025, it passed behind our star, unobservable from Earth, exactly at its moment of closest approach. For weeks, the most interesting object in the sky was hidden behind the sun. When it emerged, some observers reported it looked different, brighter than predicted, its light unusually blue. The internet did what the internet does. Data supports. Comets brighten unpredictably all the time. Gas emission can outshine dust and look blue, and an object being temporarily hidden by the sun is geometry, not strategy. Every credible measurement of Atlas, its outgassing, its rotation, its fading, matches an extremely old, extremely interesting, completely natural comet. No maneuvers, no signals. We checked. Multiple teams, multiple telescopes, including people who would have loved to find something. There was even one more twist. Measurements suggested a tiny non-gravitational acceleration on Atlas II, the same crime Oumuamua was arrested for. But this time, the culprit was caught on camera. Atlas has a visible coma, visible jets, visible mass loss. A natural rocket doing natural rocket things, which, in a strange way, is the strongest evidence in the whole case file. When the push has a natural cause, we can see the engine. With Oumuamua, we never did. And think about what Atlas's age actually implies about its home. It likely formed around a star in the galaxy's thick disk, a population so old that many of those stars have long since swollen, shed their outer layers, and died. There is a real chance that the system that built this comet no longer exists, that its sun is now a slowly cooling ember, its planets frozen or consumed. Atlas may be a surviving fragment of a solar system that is already over. An orphan, older than its own family. In December 2025, Atlas made its closest approach to Earth, and I want to be precise about what closest meant, because headlines weren't. It came within about 270 million kilometers. That is 700 times farther than the Moon. Nothing about Atlas was ever a threat. And yet that month may end up mattering more than any other, because with the comet at its brightest and every major telescope watching, astronomers collected the finest dataset on an interstellar object ever assembled, the baseline every future visitor will be judged against. So where does the Loeb debate land this time? Here's my honest scorecard after months of published back and forth. The anomaly list was real, the aligned trajectory, the early activity, the nickel chemistry, the timing behind the sun. But one by one, each anomaly found company in the natural world. Other comets with the same chemistry, orbital alignments with unremarkable odds, brightening behavior comets pull all the time. The extraordinary claim never found its extraordinary evidence. What it did find, and this matters, is a scientific establishment that now takes the question seriously enough to check. That's Oumuamua's real legacy. As you watch this, in July 2026, Atlas is outbound. It swept past the orbit of Jupiter's neighborhood on its way toward the exit, fading month by month, carrying its 7 billion years of history back into the dark. It will never return. And somewhere out there, between the stars it came from and the stars it's heading to, are trillions more like it. Which brings us to the real question of this case file. Not what these three were, but what we do about the next one. Act 4. The trap we're building. Everything about how humanity met its first three visitors was backwards. We spotted them late, scrambled to observe them as they left, and spent years arguing over crumbs of data. So astronomers are now doing something audacious, preparing the welcome party before the guest arrives. Weapon number 1. The Vera Rubin Observatory in Chile, which began its decade-long survey of the entire southern sky in 2025. Its camera is the largest ever built, and it photographs the whole visible sky every few nights. Simulations suggest it could catch interstellar visitors not once a decade, but potentially several every year, and crucially, catch them on the way in, with months of warning instead of weeks of regret. Weapon number 2 is my favorite, because it sounds like science fiction and it is fully funded. The European Space Agency's Comet Interceptor, planned for launch in 2029. Here's the trick. It launches with no target. It flies to a parking spot in space, a gravitational balcony beyond the moon, and it waits. Years, if it has to. A loaded harpoon, hanging in the dark. Then, when a pristine comet, or if we're lucky, an interstellar visitor, comes falling toward the inner solar system on the right path, the interceptor lights its engines and goes hunting. For the first time in history, we wouldn't be watching a visitor through telescopes from millions of kilometers away. We'd be flying through its tail, tasting it, photographing its surface up close. An object from another solar system, close enough to touch. And that's when the Oumuamua question gets settled, one way or the other. Because if the next tumbling, accelerating, tailless oddball shows up, we won't be squinting at a dot. We'll fly over and look. If it's a hydrogen iceberg, we'll see it sublimating. If it's a nitrogen shard of a dead world, we'll read it in the spectrum. And if it's a light sail, well, then this channel is going to need a lot more episodes. Now for the question you may have been quietly asking for 20 minutes. Could one of these things ever hit us? The honest answer: the odds in any century are extremely low, space is vast, and Earth is small. But here's the sobering part. An interstellar impactor would arrive at 60 kilometers per second or more, roughly 3 times the speed of a typical asteroid strike, which means many times the energy for the same size. In our planetary defense playbook, nudging an asteroid years in advance assumes years of warning. A visitor gives you months. It's not a reason to lose sleep. It is one more reason those early warning sky surveys may quietly be some of the most important machines our species has ever built. And there's a gentler possibility hiding in the same numbers, one scientist called panspermia. If trillions of objects have been trading between star systems for billions of years, and if microbes can survive inside rock and ice, then life itself might hitch rides. It's unproven, and it's not fringe. Serious researchers have modeled it for decades. Follow the thought far enough, and it bends back on you. Some of the visitors passing through our sky tonight will one day fall onto young planets that don't exist yet. We might not just be watching the galaxy's mail. We might be some of it. And here's the part where you, watching this, are not just a spectator. Visitor number 2 was found by one man with a homemade telescope, looking where the big surveys weren't. Today, projects let anyone help. Citizen scientists comb survey images for moving dots. Amateurs with backyard scopes provide tracking data the professionals genuinely use, and discovery apps flag new objects within hours. The 4th interstellar visitor is out there right now, inbound, undiscovered. There is a non-zero chance the person who finds it is watching a video like this one tonight. I'll leave you with the thought that keeps me up at night, and it's not aliens. It's the numbers. For every visitor we've caught, millions passed unseen while humanity was building pyramids, or hunting mammoths are not existing yet. Objects from dead stars, from worlds that were shattered, from places the sun will never take us, have been drifting through our solar system for 4.5 billion years. We only learned to see them 8 years ago. We are brand new at this. The galaxy has been knocking forever. We just started answering the door. And here's the symmetry I can't stop thinking about, partner to Casefiles 1 and 2. While these 3 visitors were passing through our solar system, 5 machines built by humans, including Voyager 1, the star of Casefile number 1, are heading the other way, out into the galaxy. To some other civilization's sky survey, 1,000 centuries from now, Voyager is the mysterious visitor on the impossible orbit. We are somebody else's Casefile. Try to be a good one. If this file was worth 30 minutes of your one wild life, the subscribe button is how you vote for Casefile number 4. The watch list is long. Signals we can't explain, missions that refuse to die, and places in the solar system that make no sense. Drop your verdict on Oumuamua in the comments. Iceberg, shard, dust bunny, or sail. I read every one. Keep looking up.